Good afternoon. And yeah, welcome to Boosting Product Development with Zephyr RTOS, Critical Reflection. I'm Moritz from Zeiss Corporate Research and Technology. And yeah, this is about the presentation I did together with Stephan, which was sitting in the front row here, and will join me later for the questions mainly. So yeah, I'd like to start with, of course, what is Zeiss as a company. Many of you know us maybe from glasses or camera lenses, stuff like that. But we do lots of other things that also involve embedded stuff and electronics and yeah, anything like, for example, for semiconductor manufacturing or medical technology is also a huge one. But yeah, also a lot of different markets. So yeah, I'm from research and development. So we're basically at the corporate level. The research department was yeah, testing new solutions, new products, new software, for example, for everyone else to then use. And this yeah, presentation is mainly. My main goal today is for everyone who's undecided whether to use Zephyr or not for a new product to yeah, convince them to basically use it or maybe to decide whether to use it. So yes, this is for us based on a true story. We had yeah, really explorative prototype where we could try out lots of new things. And this is also why a completely new software architecture came into play here with Zephyr. So we had completely new hardware, completely new software, also an app now. And the goal of it was basically to have a working firmware after 4 months. And the main issue with that was we didn't even have the full hardware developed completely yet. So we had to develop the firmware without the hardware, merge them at some point. This is what's depicted here. The design start basically of the whole prototype hardware and everything was 3 months before the start of the firmware project. And then basically, yeah, we noticed, okay, we don't have the prototype ready yet as hardware, but we need to start with the firmware now, basically. And yeah, then that was month 1. We needed to, yeah, find some way to work without hardware, and at some point, month 3, fuse it together with the actual hardware that was ready then. So yeah, after 4 months, I can say so much. We have achieved the goal of having a fully working prototype based on Zephyr. So yeah, talking about the basic architecture, it is of course an optical system. Unfortunately, I can't tell exactly what the product is so far. But yeah, it has some motors, some actors, some sensors, of course, some optics in between that. And then we have the microcontroller as a central unit, Bluetooth, and also some user interface with some buttons, some lights, and yeah, that's the interface to the user then. And that's the yeah, project I'd like to talk about. So yeah, the decision basically, why should we use Zephyr? It started with the whole point of, okay, we need to be quick. We can't start with, okay, we know which components we want to use. Let's start with the data sheets and implement all the I2C drivers and everything ourselves. So it was really great to have such a huge ecosystem with lots of component drivers already included. And also in such a mature state that we knew, okay, if we have this prototype ready, this can and will make it into the final product. Also a big part, we can test on different hardware, different SoCs, for example, but also with different chips, because also, yeah, the prototype wasn't completely built yet, as I said. And yeah, also Zephyr for us at Research and Technology, of course, it's a huge new valuable thing we want to learn. Zeiss is also a project member of Zephyr. So yeah, that was also a reason we needed to look into that to spread it across the different departments as well. So yeah, fully open source, of course. That's also a big point. We have no delays for support. We can just go to anyone who has worked with Zephyr, give them money, and they will help us. And we don't have much licensing issues for the final product with how many, how much we sell and stuff like that. It always depends on proprietary software. It's a lot harder, but I don't have to tell you that here probably. So yeah, the biggest question for me, it was the first Zephyr project. And the first thing I noticed about Zephyr is it has a really steep learning curve. So that's the question then, is that learning curve actually worth it for a product team? And also for individuals who just want to try out stuff that maybe becomes a product later. So yeah, it has a really huge code base you need to look through. It has many new concepts with device tree, kconfig, whatever. It's a lot of new concepts. And the concepts are also quite opinionated. So you need to know how they how the concepts want to be used to really work quickly and well with them. And of course, yeah, it's way more complex than most just kernel RTOSs, but also we didn't even need the real-time aspect that much. So there was really not much of an alternative that comes with so many drivers. So yeah, it has all the tooling for QA, for the workflows, build pipelines, anything, documentation. There are best practices. It has a lot of documentation actually that is really great. It has a community, which is also really important. Yeah, a big thing also is just it works the same across all different kinds of SoC or microcontroller vendors, basically. So yeah, for us, we're a huge corporation. Many departments work with many different manufacturers of microcontrollers. And this is just a big thing for us where we can have one thing that we could use everywhere. So yeah, the next 25 minutes or something, I will talk basically about what we have learned there, or what we found great about Zephyr, what we found not so great, and what we wish we had known before during that project. And we have a few different categories here. First one is hardware resilience. So yeah, having vastly different hardware environments there. First thing we learned would be develop only on the hardware you need, which otherwise is a lot harder. But yeah, here basically we just started with a Nucleo board and did almost everything with that. And yeah, either without anything, just with, for example, developing the app with a Bluetooth interface, just a sensor for library development, to just develop a library for just this sensor, and a couple of I2C components to just do driver development against these components. So yeah, we really started from this small board and extended it with the prototype hardware we needed. And then the next step was, of course, the integration with the full prototype. And when we received it, we had no issues at all with the especially Bluetooth interface and protocol, of course, because it's all the same. And with the sensors, with the components, everything worked really smoothly. The biggest thing we had to change there, of course, and that is always a requirement with Zephyr, is the device tree if you have different hardware. But yeah, basically we just had to write the board definition for our prototype, and that was it. Everything basically worked. And as that went so smoothly, we actually had, before the prototype, a little lab setup that was based on an Arduino. So we thought, okay, maybe we could try to put the same firmware on that. And that worked surprisingly well as well. But yeah, we skipped a few parts that we didn't need anymore, because that's, of course, a lot more effort if it's not the same hardware you have. But yeah. So yeah, second point we learned here, use many shields. Shields in Zephyr, for those who don't know yet, there's basically you have your board, which is the hardware on the system on chip or the microcontroller, and then basically the idea was like from an Arduino, you would have a shield you put onto that board. In our case, we took this a step further. We had actually from ST, there are module versions of some chips that are also in Zephyr itself boards. So we basically took that and we specified our main board itself, where that module was soldered on, as a shield. And that was really flexible because switching between various iterations, we can really easily basically inherit from that single little board that is basically just a chip. So yeah, basically any connection in Zephyr can be a shield. It could be a solder joint, could be wires with the Nucleo board, for example, as well as classical heads that have a defined interface. And And the third one, of course, because we didn't have the hardware yet, you can use off-the-shelf hardware to just attach it and test it with your actual application. Basically every part of our application was toggleable through kconfig, so we could just say, okay, hey, we don't want that part because we don't have the hardware yet. We just want to test the other parts right now, and this works really well. You can just attach it, and it just works. So what you also did was use CMake presets a lot to keep track of different configurations. Big advantage is that the configuration just has to be done once. It is the same on continuous integration and locally. You can easily catch mistakes that way, other than if you would have to specify each configuration manually. You can just say, okay, I have these 5 presets, I test all of them in CI, and it works. We had a little if-def in there for temporary configurations, but usually that means basically, okay, if we have this in the application, if we have this shield installed, for example, then do this. Usually with Zephyr, you can just define different shields or just enable the whole subsystem or write a simulation for that with a stable API. That is a lot better here, but it works for quick tests as well. An issue we encountered with that is that we now want to switch to MCU boot. And there we need sysbuild for that, and it makes it a lot harder to use CMake presets if that's possible at all. So we switch basically back to simple shell scripts here. That's maybe a thing. I'm not sure if Zephyr strives to have like a configuration system on top of that, but that's something we might want for the future, we might build for the future, or we might also have a solution that we just don't know yet. So and also in the easiest case, just use simulation, just develop without any hardware at all. We could use the native sim to just run the complete firmware on a normal Linux machine as a single binary, and even use the host's Bluetooth adapter, so we could just have the PC running the firmware and connect from the app with a smartphone. And of course, for app development, that is really convenient to just not need any hardware at all for developing against an embedded platform and the firmware itself. So next one included drivers. Of course, that was a really huge one for us. Save a lot of development times by using what's already there. Zephyr is really awesome in that. There are more than 2,000 device bindings. I'm not sure if it's even more now. And what we actually also do, we checked if a component is supported in Zephyr before we selected it for the electronics. That is a really good approach, and I think if you don't do that, there's a good chance that you will get stuck at some point because you need to develop a driver. Sometimes there's no way around it. Also, there are better or worse drivers. It's not always clear how complete a driver is, if it's limiting in some factor. So it is still required to look into the driver's code. Of course, the simpler the component, the more complete the driver in most cases. Power management is, for example, always something to look out for if you need it, to check in the drivers if it's supported. And I have an example here as we switched from, I think it was 3.7 to 4.0, the Zephyr version. There was an old driver called GPIO PCA 953X for an GPIO expander series. And they all have a really similar interface, but not the same. And for example, an issue we encountered here, the name suggests that, okay, this supports everything for the X at the end. But for example, with the 9, that one was not supported by Zephyr. So yeah, we thought, okay, we can fix that, look into the code. And yeah, this driver had a lot of magic numbers in there and needed a lot of rework. But luckily then Zephyr 4.0 came along and there was the PCA series, which was way more abstractly defined with much easier to add also new components. So there's also a lot happening there, lot of development in the drivers, and next one would be to use stable and specific APIs because that makes it easy to exchange components. Of course, if you're coming from normal embedded development without Zephyr, from the more low-level approach, it is easy to just think, okay, I have this I2C chip. It just has 2 registers I need, basically. I will just write the registers myself. You can do that with Zephyr, but it's not really a good idea because it is really unflexible. So for us, for example, if you have a light source that you just want to toggle, and that is behind the GPIO expander, then you could, of course, write I2C bytes to the GPIO expander directly, or you could just go the way and implement the device driver for that and use the GPIO subsystem here. There's also, of course, always the question, we have a light source here that can just have a Boolean state off or on. Of course, for an optical system, that can be a lot more complex. So it would be at some point, of course, then ideal to write your own API on top of that, using the abstraction that Zephyr provides and building upon that. So yeah, next up, the little helpers that come with Zephyr. That, basically is everything where Zephyr makes development more flexible and more streamlined. The first one would be West, and West is the meta tool of Zephyr. The best thing about it is basically all you need to know when you need to build firmware for any Zephyr project. So you can just take any repository and just run West commands and it will build for the hardware. You can flash it to the hardware. If you don't need to look into the code, that is, just gets you started. It makes it really easy. It's a great tool. You can manage dependencies. You can flash the firmware on various boards, like I said. You can estimate the flash size it takes up. You can also define custom commands, generate SBOMs. It just does a lot of things for you. And a big thing about that is it is manufacturer independent. Otherwise, with ST, you would have one set of tooling. Okay, now I want to do the same for NXP. Then you have to reinvent the wheel, basically, or check their tooling, rewrite your CI pipelines, everything. It's really great. Logging is also something, usually when developing a prototype, that is not something you would think about first if you would have to do it yourself. With Zephyr, it comes free. You don't even need a debugger to figure out what your code does. You can just add log statements everywhere and enable the log for the components you want to dig into. And also, of course, then later in the product for repairs and maintenance, you can just add some flash storage and put the log there. And if something breaks, you can just go read what went wrong. It gives you a lot of flexibility here that is really similar to what's possible in high-level languages. The next one would be the shell. That is also for everyone who knows Zephyr, a really straightforward one, or for everyone who knows Linux. But yeah, when starting with a barebone firmware from scratch, that is also not a thing you would think about. Just letting you interact directly with the firmware is so convenient also for electrical engineers, for example, who are building the PCBs and want to test them. You can just send them a few commands they can use to try out various components, which work out really well for us. So yeah, you can also define custom commands here, for example, light source on, and that way, yeah, also for maintenance, it makes stuff really easy. Yeah. So yeah, was it worth it for us? Definitely. We were much faster and much closer to the final product, and I can also tell that we're yeah, coming quite close to the final product. There's of course a lot of other things to think about, like testing now with Twister, hardware in the loop tests, stuff like that. Certification and some things, and that of course all takes a bit more time. Zephyr also helps with a lot of things here, especially for example with the SBOM generation and stuff like that. But yeah, the prototype is running. We have no blockers to the final product, and yeah, we didn't even have to use any specific firmware for debugging to. Yeah, when we received the prototype, basically all the issues we encountered and thought, oh, what did we do wrong, were electronical issues. So it went really, really great. So yeah, also, of course, the open source spirit. If we implement something that's not part of our core business, why not share it? That's also important for us. We, of course, avoid maintenance during updates and security patches, because in most cases across the whole Zephyr project, from one version to the next, there is a little thing that needs to be done in a lot of files. And if every corporation was using it in their products has to do that themselves, it's a lot easier to have all the drivers in the same place. And also, yeah, for example, we contributed a bit through the stepper driver as well already, also through Stephan from Navimatix and his company. And yeah, big thing, of course, also internally, if we have a project that is focused on development speed, and the next one, or no, other way around. Even though this was a project that was focused on development speed, we have stuff that we can just reuse in other future projects. And just as of now, we already experienced that we are asked, okay, and can we take this part and reuse it? So that would be the next project here. That yeah, then has a dependency on an internal component, and stuff like that is so convenient with Zephyr. I don't really know of another embedded ecosystem that does this so well. So yeah, in our eyes, it really was a huge success. And yeah, I'm really looking forward to what's coming with Zephyr next. Thank you. For the questions, Stephan, you can join me. A lot of questions. Then let's start on the front. So the question is, we are a huge company. If all teams are already convinced by Zephyr, of course not. There's a lot of legacy projects, of course, that will exist for 10, 15 years, and we try to really establish Zephyr as the default for new projects. But of course, that has to be specific to the users within the company. We are quite heavily networked within the company, though. We have a internal Zephyr community as well, where we discuss stuff and share ideas. Have some kind of internal platform. So this is really a big thing that we want to achieve in the future. But as of now, of course, you have to think new in every new project. The question was about footprint and if we run into issues there and maybe needed to use a bigger chip. For us, there weren't that many options actually for chips we could use due to the requirements. So we had to do with that what we could. We ran into a bit of memory issues in the end, but nothing that couldn't be solved. So Zephyr is also makes it quite easy to solve that. Yes, we basically had one application repository and of course then Zephyr as a dependency, and the question was, yes, we use Vest to manage that multi-repo structure. In our case, we use a pure vanilla version, basically. Yeah.
From time to time, half a year, we switch to the next release in upstream. Or it's a classical downstream development. Yeah.
Do you maintain any local patches on top of Zephyr?
In this project, no. Yeah.
When it comes to upstreaming stuff to the Zephyr project, this is something many companies are very reluctant with. I have some inside information, but can you maybe tell us how long did it take at Zeiss to involve or to develop a process that enabled you to do that?
That's a question that's probably best suited for Holger, our OSPO, who is also here today. Not sure if in this room, but we do now have a process that works quite well, in my opinion, for that.
One comment that Zeiss is really happy that they have a contributor on the hand, us. Zeiss is happy that they have a partner in this project that contributes the code to the community. So that is a really interesting thing for the companies. They spend too few time for this on focus, and so it's really important that there is a binding between the commercial interests and the community interests, and that's maybe contributors like us.
Yeah, also one tip for everyone who's starting a Zephyr project that they want to become a product and they're doing it for the very first time. The learning curve is quite steep, and I was really glad to have Stephan on the team there. It is great if you have someone who already knows their stuff, especially with Zephyr. So either have someone internally who tries it out and develops the knowledge there, or also take on external support there. It helps a lot to have someone who knows how it works and how the opinionated concepts want to be used, I would say.
One comment to that. Don't fear the step to move from your legacy code base to a Zephyr-based code space, because each person that learn to work with Zephyr is able to work with the next project in the same situation, in the same framework. And so you got a lot of more on tooling, on framework for the future than in the classical legacy way. So that is a reason also for Zeiss to do this in a balloon. Maybe it's a balloon project.
Considering the Zephyr ecosystem, that because you mentioned testing, how much could you achieve with the existing ecosystem of testing, and were there roadblocks or limitations?
We have learned that we can be easier with the Zephyr framework dive into an hardware-in-the-loop pattern. And so that was also one point to do this step to go on with Zephyr. Because with Twister, you have an adaptation system where you can be go on different specialized hardware-in-the-loop environments, and the front end for the developer is exactly the same. Maybe you have a complete different infrastructure in 10 years, but the hope is high that the interface over Twister is exactly the same.
So I'm just curious to know whether you know where you're going to choose Zephyr, because we know there's so many platforms that use Zephyr. In your case, you can even explain that because there's so many of the majority of them we don't know. So I'm just curious to know where companies like you make real products with Zephyr. Where do they plan to put that line? This software uses portions or whatever Zephyr stuff that you know?
Yeah, for us, most products are business to business, so it's probably in some contract or manual or something. For this project, I actually want to also have it on the Zephyr products using Zephyr page, but yeah, we will see about that in a couple of months.
Marketing.
Do you have numbers what using Zephyr cost compared to some other offers? What additional overhead is Zeiss?
For this project, the alternative would be having no RTOS at all, just develop it from scratch. And we originally had a quote on that, which I would say in the end was almost the same as we had now with Zephyr, but it was only for the prototype. So starting from that, the question is, okay, to get from here to a product-ready firmware that we can make in the future, what else would it cost? And with Zephyr, that is something where we just know, okay, we can trust it in this case.
I have a question about homologation, because your product will use Bluetooth. So is there any part of Zephyr that's being used, and would that support the certification process?
A lot of the certification. Sorry, I'm supposed to repeat the question. Sorry. So the question was whether Zephyr supports us with a Bluetooth certification. What supports us more with the Bluetooth certification is that we can use that ready-made module by ST. That then also includes most of the certification we need there. Of course, other than that, it's more from an electrical side, and